Good afternoon. This math video is on comparing and ordering rational numbers, and this should be page 28 in your notebook. So let's get started. So what is a rational number? It's any number that can be written as a fraction. The word ratio is a comparison of one thing to another. So fraction, ratio, those are two words you'll hear me kind of using interchangeably. This includes percents, fractions, repeating decimals, and terminating decimals. All right, so how do we compare and order rational numbers? The best thing to do is to change them all to decimals, just because place value is really easy for us to compare. When you start changing everything in fractions, you have to find a common denominator. It starts getting a little harder. Percents, you have to find a common denominator of 100. So it's just easy to change them all to decimals. And then one other thing I want to tell you about is that when we're talking about negative numbers, so that's like owing someone money or being in debt, the larger that the negative value is from 0, like the further away it is, the smaller the number actually is. So you can think about absolute value as being the distance away from 0. So negative 20 is actually less than negative 10 because it's further left on the number line. And we're actually going to get into integers later on in this unit. So really quickly, just a nice review. To go from fractions to decimals, you just divide. Your numerator is going to be inside. Your denominator is going to be outside. To change from percents to decimals, you just move the decimal 2 places to the left or divide by 100. And that's just the easiest way to change our numbers. So we're going to compare these two values, and we're going to use a less than, greater than, or equal to symbol. We're going to change this, since this one's already a decimal. Let's change this one to a decimal. So this is saying 3 divided by 4. So 3 divided by 4. 4 can't fit into 3 holes, so we're going to make it 30 tenths. 4 can fit into 30 tenths 7 times, so it gives me 2 and 8 tenths. Subtract that, and that gives me 2 tenths, but 4 can't fit into 2 tenths, so I'm going to bring down another 0. 4 can fit into 20 hundredths, and it can fit into it 5 times, so 0.75.
Miss Brittany Jones, please call the front office. Miss Brittany Jones, please call the front office.
So my new problem is actually 65 hundredths compared to 75 hundredths, and which one is bigger? I'm going to use this symbol. So the way we would read this is 65 hundredths is less than 75 hundredths. All right, moving on over here, we've got a percent and we've got a decimal, so let's change this percent. Remember, with percent, you can just divide by 100 because that's what percent is. It's out of 100, so we're going to divide by 100. Now, a quicker thing to do is just to move the decimal 2 places to the left, because I'll even show you that when dividing by 100, that's what it does, is it makes your place value smaller by 2 places. So 27.8 divided by 100. See how I move the decimal? 1, 2, and then look, there it is. So 0.278. So negative 0.278 compared to negative 0.18. So what you want to think is, remember back up here, negative numbers, the further they are left, the smaller they are. So this one is actually going to be further left because it's further away from 0. So this one's actually less than. This one's actually greater than. So we're going to go ahead and open up the inequality to the negative 0.18. So therefore this sentence says negative 2.78 is less than negative 0.18. Okay? Or negative 278 thousandths is less than negative 18 hundredths. All right, moving on. Now we've got a percent and we've got a fraction, so we've got to change them both to decimals. So let's just divide this one by 100 or use our quick trick by moving the decimal place 2 places over. So that gives me 45 hundredths, because 45 over 100, that's 45 hundredths. And then 3 over 7 is 3 divided by 7. 7 can't fit into 3 holes, but 7 can fit into 30 tenths. It can fit into it 4 times. That's 28. 2, 0, twice. That's 6. Okay, so I'm going to get a pretty big number here. So I'm going to go ahead and just do it with a calculator just to save time. So 3 divided by 7 gives me this long, long, long decimal. Okay, so I can actually go ahead and stop because I'm looking at the hundredths and the hundredths, and I can tell that this one's going to be bigger anyways because 5 is bigger than 2. So Oh, I'm sorry that this is so messy. So the inequality is going to open up this way. Again, I apologize for the messiness of this problem. I'm going to go ahead and white it out because it did get kind of messy. So just know that 3/7 in the calculator did convert to 0.42857, blah, blah, and just kept on going. And I compared my hundredths place, and I saw that the 5 was bigger than the 2. Okay. All right, moving on, so 2.65, it's already in decimal form, so I'm going to change this 7/8. Again, just for sake of time, I'm going to use a calculator, but we know that this is just doing division, so 2 point, and then 7 divided by 8. 7 divided by 8, 0.875 right here. So this is 0.875. So which one is bigger? It would be this value right here. So this is the less than symbol. So 2.65 is less than 2.875. Okay. All right, now we've got some decimals and then some fractions, and they're negative. So remember, the further left something is, so the bigger the absolute value of the negative, the smaller the number is. And let's go ahead and do 1 divided by 15. And again, just for sake of time, I'm going to go ahead and use a calculator. So 1 divided by 15 is 0.06 repeating. And I already know that negative 0.09, well, since that's a bigger negative value, it's going to be a smaller number. So therefore, this one's bigger. All right, and then let's look here. I already know that this one's going to be smaller because it's a negative, and negatives are always smaller than positives. But we can go ahead and change this to a decimal. So 0.18, or excuse me, 18%. When we divide by 100, it gives us 18 hundredths. And then 1 divided by 9 gives us 0.1 repeating. And it's negative 0.1 repeating. And I know that negatives are less than, so I'm going to actually open up to the 18%, so the 0.18. Okay. All right, and then moving on here, we want to order the following in ascending order from least to greatest. So we just need to change them all to decimal form. We're going to put those in order, and then we'll change them back to their original number. So this is 4.6. 42% is 42 out of 100. So let's put that over 100. So we've got 4.6. We've got 42 hundredths. We've got 4, and I'm going to change 1/8 to 0.125. And then 0.4. All right, I'm going to look at what my smallest value is. It's going to be this guy right here. So I'm going to write that one first. And then my next value is the 42%. And then my next value is the 4.125, which is the 4 1/8. And then the 4.6. So it's going in order from least to greatest. All right, moving on here, I've got a fraction, I'm going to change that. I've got a fraction, I'm going to change that. And then these other two are already decimals, so I'm good to go. So I really want to change these two. Again, just for sake of time, let's use our calculator. So 1 divided by 5 is 0.2. This one's 0.3. This one's 0.375. This one's 0.28. And we want to put those in order from least to greatest. So I'm going to look, and it looks like this 0.2 is the smallest, so that's 1/5. And then the 0.28 comes next. And then the 0.3 comes after that. And then the 3/8 is my biggest value in this problem. All right.
Ms. Aitken, please report to room 310. Ms. Aitken, please report to room 310.
Okay. This is going to be a challenging one because these are all negatives, so you have to kind of think the opposite of what we normally would with positives. So remember, the bigger the negative value, the further away it is from 0, the smaller the number actually is. So let's go ahead and change these all to decimals. So this one's a decimal, that's a decimal, so we really only have to change these two. So 1 divided by 9 is going to give me negative 0.1 repeating. This one's negative 0.138. And this one's going to be negative 0.75. Okay, so what I want to do is I want to go least to greatest, but remember, the bigger the negative, the smaller the value actually is, because it's like you owing more money, so you have less and less money. So this one's actually going to be my smallest number. So negative 3/4 is my smallest number, and then negative 0.74 comes next. And then it looks like negative 0.138, and then my biggest value is actually negative 1/9. And then my last problem, it looks like I got to change this one. I need to change this one. It looks like these values actually repeated, so let's white one of those out because we don't need that. So here, let's go ahead and take this one out because it's the same value. And then we've got this last value right here. Okay, so let's change these. So 4 1/5 is 4.20. Then I have 4.209. And then I have, if I move this 2 places to the left, I have 4.05. And then this is 4 and 1 divided by 50 is 0.02. And I want to go least to greatest. These are positive, so it's kind of normal thinking of the order. So this is going to be my smallest, so 4 1/50. And then after that is going to be the 4.05, which was given to me as a percent, so 405%. And then after that is going to be my 4.20, so my 4 1/5. And then my last one is going to be 4.209. Okay. And that's it for these notes. When you open up on the inside, it's just a bigger page of what we just did. Just be careful because it does say write the following from ascending order, but then down here it says write the following in descending order. Just be careful with your negatives. Again, the bigger the absolute value of a negative sign, so the bigger the negative number, the smaller the value actually is. So just complete these 8, and then you also have your QR code project to work on, so please do that. If you have any questions, please comment at the bottom, and I can answer those tomorrow in class. All right, have a great night.